Now we're going to look at how we can find complex roots, again using de Moivre's theorem. Okay. So we've got our polar number that we're starting with, or polar form of our complex number, and our w is not equal to 0. So w has n distinct complex nth roots given by this formula. Okay, so this one is for radians, this one is for degrees. So notice with the r value that we're taking the nth root of r. So again, whatever kind of operation we're doing is the same thing that happens to the r value. So if we're finding the complex nth roots, so if we're finding the second roots, then this would be the square root. If we're finding the third roots, then this would be the cube root, and so on and so forth. And then plus cosine of theta plus 2 pi k over n. So we've got two variables here that we're talking about. So the n is what kind of root we're taking. The k is down here, where our k value is all the numbers from 0 all the way up to one number before our n value. So if n is 3, then our k values are 0, 1, and 2. Okay? So we've got two different things here. So we're dividing by our n value on our thetas, and then we have to add this plus 2 pi k, right? So this is, we're looking at our coterminal angles for this, and then our k is different values depending on what kind of roots we have. So let's take an example. So we want to find the complex fourth roots, so that means that n is 4 for this complex number that's in polar form. Write the roots in polar form with theta in degrees. Okay. So then here we want to take the fourth root of 16, which is the r value, and then we're going to do cosine. We're in degrees, so I'm going to be using this one right here. So our theta, which is 120, plus 360k, and I'm leaving that k value in for right now, and then we'll plug it in just a minute. And then we're dividing by our n value, which in this case is 4. Okay? So then we get plus I sine of the same thing, which is 120 plus 360k divided by 4. So then, if we simplify our 16, that gives us 4 and 4, and then that breaks down to 2 and 2 and 2 and 2, right? Because it's the fourth root, we need groups of 4, so we have a group of 4 2s. And then I like to simplify each part of this individually. So I like to take the 120 divided by 4 and then the 360k divided by 4 and simplify that part, and then use that to help me plug in the k values. So if we take 120 divided by 4, that gives us 30 degrees. So we now have 2 times cosine of 30 plus, and then if we take 360 divided by 4, that gives us plus 90k. And then plus I sine of the same thing, so 30 plus 90k. So now what we do is our k value is from 0 all the way up to 1 before the n value. So that means since n is 4, our k is 0, 1, 2, and 3. So that means that I need to plug in 0, then 1, then 2, then 3. Okay. So when we plug in k is 0, we get 2 times cosine of 30 plus 90 times 0, which is just 30 plus 0, which is 30, plus I sine of the same thing. Right? So then this is 2 cosine 30 plus I sine of 30. Now, when I'm plugging in k equals 1, I'm going to do 2 cosine of 30 plus 90 times by 1 plus I sine of the same thing. So here, 90 times 1 gives us 90, and then we add 30 to 90, which gives us 120. So then this is really 2 times, forgot a parenthesis here, cosine of 120 plus I sine of 120. Okay. Now, if you notice, between 30 and 120 is 90 degrees. That's because every time we're plugging in a k, we're going up by this amount. This is why I like to split it in this manner. Okay? You can just plug it in and do 120 plus 30 times 0, then divide by 4. 120 plus 360 times 1 divided by 4. Okay? But here, if you split it this way, I can tell that I'm going up by 90 each time. So rather than plug in, I just need to think, okay, I'm going up by 90 more from 120. So if I go up by 90 more from 120, then that leaves us with 210. So then when I have k equals 2, we have 2 times cosine of 210 plus I sine of 210. All right. So then I feel like there's less arithmetic to do when we do it that way. So for k equals 3, I'm going to add 90 more to the 210. So then that gives us cosine of 300 plus I sine of 300. Okay. So all 4 of these are the roots. So these are our complex fourth roots. So we've got 1, 2, 3, 4, and that's our complex fourth roots for this number that's in polar form. Okay. So here we want the complex cube roots of this complex number that we need to put in polar form, okay, in order to find the roots. So now when we get our answer, we're going to write it in rectangular form. So there's a lot of switching back and forth, which is not our favorite, but it is still something that we can do. Now you can pick if you want to do radians or degrees because you're putting it in rectangular form, which means that you can pick according to your heart's desire. So I'm going to show you radians since the last one was in degrees. So if we want the complex cube roots, that means that n is 3. So I first need to put this in polar form. So our r value is going to be the square root of negative 1 squared plus negative root 3 squared. So I square 1, which is 1. I square negative root 3, which is 3. Take the square root of that, which is 4. The square root of 4 is 2. So our r value is 2. So now we find the tangent of theta is b over a. So our tangent of theta is negative root 3 over negative 1. Okay. Well, this means that I need 3 fingers on the right side and 1 finger on the left side, or my y value is root 3 over 2 and my x value is 1/2. Okay. Because we're in the third quadrant, I know that my point's in the third quadrant because we went left and down, or we both have negatives. Both of these have negatives, so they put it in the third quadrant as well. So we want if this reference angle that gives us 1/2 root 3 over 2, which would be where we've got 3 fingers on the right and 1 finger on the left. So that's our 60-degree reference angle, which goes with pi thirds. So pi thirds in the third quadrant is 4 pi thirds. So our theta is 4 pi thirds. So now my polar form of this number, negative 1 minus I root 3, is 2 times cosine of 4 pi thirds plus I sine of 4 pi thirds. Okay. So now I want to find the cube roots of each one of those. So we're going to take the cube root of the r, so the cube root of 2, and then times by cosine of 4 pi thirds plus 2 pi k all over our n value, which is 3, plus I sine of the same thing. Okay. Now, remember, when you're dividing by 3, that's really the same thing as timesing by a third, right? So 4 pi thirds divided by 3, this flips and multiplies, so it's really 1/3. So this gives us 4 pi ninths. Okay. So here we would do cosine of 4 pi ninths plus, and then when I do this part, it's just 2 pi thirds k plus I sine of the same thing. So 4 pi ninths plus 2 pi thirds k. So now this is what I would be plugging my k value into. So I'm going up by 2 pi thirds each time. Okay. Now, you may want to think in terms of getting this to a common denominator. So if we think of 2 pi thirds in terms of ninths, so that we would have a common denominator, to go from 3 to 9, we would have to multiply by 3. So that means I multiply this top by 3. So 3 times 2 gives us 6. So 2 pi thirds is the same thing as adding 6 pi ninths. Okay. So if we plug in k is 0, and then remember it goes all the way up to 1 before our end value. So we need 0, 1, and 2. So then we're going to have the cube root of 3, which I can't do anything to simplify that, times by the cosine of 4 pi ninths plus 0, which is 4 pi ninths, plus I sine of 4 pi ninths. And then the cube root of 3 times by the cosine of, and then we're going to do 4 pi ninths plus 6 pi ninths. So 4 plus 6 gives us 10 pi ninths, plus I sine of the same thing. And then we're going to have the cube root of 3 times by the cosine of, we're going to take 10 pi ninths and add another 6 pi ninths to it. So that gives us 16 pi ninths, plus I sine of the same thing. So now we want the roots in rectangular form. So what I'm going to do is I'm going to evaluate each one of these. So we're going to do, this one is not on our hand trick, because 4 pi ninths is not one of our special right triangles. So that means that I need to use my calculator to evaluate it. So I need to be in radians, because this is in radians. So we're going to go to our calculator, make sure we're in radians. So once we're in radians, then I'm going to do the cube root of 3. So remember, to get to your cube root, you can do math, and then it's the fourth one down is the cube root. So the cube root of 3 times by, whoops, I need to get out of the root, times by the cosine of 4 pi ninths. So 4 pi divided by 9. So 0.25. So this gives us 0.25. And then I need to do the same thing, but the sign. So I'm going to do second enter, and then I'm just going to change my cosine to a sine. Oh, okay, that works. So we get 1.42. So plus 1.42i. So then I'm going to do the same thing with 10 pi ninths. So I'm going to do second enter, but I'm going to go back and I'm going to change this to 10 pi ninths. This one's sine, so it'll be minus 0.49i. And then I'm going to go change this to cosine. Maybe. There we go. So that gives us negative 1.36 minus 0.49i. And then we have 16 pi ninths. So then I'm going to do second enter, but change it to 16 pi ninths. Your delete button is to the right of, 2 to the right of the second button, and that will delete a character. If you need to insert something so that it doesn't erase over it, you do second and then the delete, and then it will insert it without writing over on your calculator what you have. So 16 pi ninths gives us 1.1, and that was the cosine one. And then we're going to do the same thing, but times by sine. Let me go back and change the cosine. Oops. So I hit delete and then sine. Depending on which one, you may have to hit second and then insert, which is above the delete, and then the sine value. So negative 0.29293 I. Okay. So then these three are our answers for the complex cube roots of negative 1 minus I root 3. Okay. And that's how you find your cube roots, or your nth roots, rather, of your complex numbers that are in polar form. And then you can switch it back to rectangular form if you need them in rectangular form.